How's it going, everybody, and welcome back to our Cisco Enterprise series. In this video, we're going to be moving to our next stage of our deployment of OSPF in the HQ location by going through and doing some optimization. The first thing we're going to go do is we are going to, on every one of these point-to-point interfaces between any of the devices that are considered infrastructure devices, anything that's routing, we're going to flip all these interfaces over to point-to-point mode. And the idea here is to optimize our OSPF database and remove the type 2 LSA. So remove the DR-BDR election between all these routers, and with the intention of, again, removing the type 2 LSA. So let's go ahead and pull up router 25. So again, we're going to basically remove all of this stuff. Network link states. So the network summaries and this stuff right here, this is your type 2 LSA. Up here we have type 1. Can't get rid of those guys. You gotta have those in place. But we can get rid of the type 2 LSAs. So without any further ado, let's go ahead and begin this process. We're going to start on switch 7 and work our way up. The process is very, very simple. I'm going to go further over than I thought. Okay, there we go. Alright. So what we're going to do is go to the interface level. So interface gig 1/1. And we're going to type in IP OSPF network type is going to be point-to-point. Now there is other point to options. You have point to multi-point as well, and then if you wanted to take it a step further, you could do point to multi-point. If I do multi-point here, then there's non-broadcast. So we're not doing that one, we're doing point to point. So I'm going to do that, and I'm literally just going to copy this config in, and you can see that the neighbor went down. Now if I go to XR41, we should have an issue, and the issue is going to be that, go ahead and log in here. If I do a show IP, show OSPF neighbor, right, we're not going to have a neighbor, or I'm sorry, we are going to have a neighbor to 7. Okay, that the neighbor is still going to form if the network type is incorrect. But if we do a show OSPF database, and if we look for the advertising router for these subnets right here, notice it's router 8 and not router 7 or switch 7. And that's because the change in the network type, XR41 and switch 7 on this link do not agree on the network type. So if you were looking here and say show OSPF interface gig 00002, we are broadcast as our network type, where switch 7 is not. So it tells you right here, it says received hello from 10.0.0.0.41 on gig 1/1, indicating a potential network type mismatch. And this is the error that I want you guys to be familiar with. If you see this in the debug, I think it'll actually work in the show IP, show OSPF traffic, I think is the command. No. Is there events? Events. We're going to look at let's see here. I'm looking to see if there's anything specific. I don't see anything. We might have to go up here and do pipe include network. Yeah, see it's sometimes I don't think it'll show it to us here. But if we were to look at, the cool thing about it is if we were to look at the show logging pipe include network, right there. So that's one thing you could do as a quick show logging pipe include network to see if there's a network type mismatch. So the quickly easy fix for this would be go to 41, go to global config, and do a router OSPF 1 area 0 interface gig 00002 and type in, the command is going to be network, and it's going to be point to point. And show config, that's going to be the syntax that you're going to want to apply, and then commit that. And then as soon as I do that, the adjacency, the neighbor's still there, but if we look at the database, we should see that coming through. We see the type 1 LSA right there, which is good. I might have to update this. Let me look at the database, network, and we're looking at advertising router of 10.0.0.7. About 8. I want to look at, oh, that's why. Wrong IP address. So I don't see 7 in here on the link. And so you won't see 7 here because obviously there's no DR/BDR election. But if I was to grab this, it's going to tell me that we have the DR and what we've got attached to it, right? So that's this connection right here. There's also the loopback. That's right, the loopback is the same, so 7, okay. So at this point in time, this isn't exactly the greatest output for this, but the idea is that by narrowing this down, we will start to see an elimination of the type 2 LSAs, which is what we want to see. So that was the easy part. So we'll go to switch 8 and do the exact same thing. So we'll go to interface gig 1/1, and we'll type in IP OSPF network type is going to be point to point. And then on Nexus 49, we'll log into this guy. Actually, we're already there. So we'll type in interface ETH 1/3. We'll type in IP OSPF network type is going to be point to point. And there we go. So then if we do a continuation of this, I'm not going to waste any more time looking at it at the individual level. So to try to speed this process up a little bit on some of these bigger boxes, I'm going to go to say XR41. Well, we'll go 25. On 25, it's an easy config. Interface range, gig 0/0 through 3. We'll type in IP OSPF network type is going to be point to point. And then we'll do the same thing on 57. It's way on over here. 57, we're going to go to global config, interface range, gig 1 through 5. IP OSPF network type is point to point. And then we're going to go to 41 and do the exact same thing we did just a minute ago. We'll go to global config, router OSPF 1, area 0, interface gig 0000, network point to point, gig 1, and then gig 3. And then we'll commit that config. And then we're going to go over to Nexus 49. Did I already do it for 49? I did. Well, I did it for just one. So interface ETH 1/1 through 5. And we're just going to run the same command again. We'll do that. And then now that that's been done, the bulk of these are done. We'll grab 50 and 51 real quick. We're going to go interface ETH 1/5, IP OSPF network point to point. 51, same thing. Interface ETH 1/5, IP OSPF network point to point. And then we're going to go do switch 13. And we'll go to global config, interface range, gig 0/0 through 3, IP OSPF network point to point. We'll do the same thing on 14. Interface range gig 0/0 through 3, IP OSPF network point to point. And then on 33 and 34, respectively, interface gig 0/0, IP OSPF network point to point. We're gonna do show, probably be faster just to type it in. Interface gig 00, oops, IP OSPF network point to point. And then on 58 and 59, respectively, interface gig 1, IP OSPF network point to point. Do show history. Oh, this one won't do it for me either. So we'll go to 59 and knock that out real quick. Interface gig 1, IP OSPF network point to point. Okay, now that we've done that, I'm going to go back to 25. Now, I wasn't doing any SPF updates or anything like that because I just didn't. So I'm going to go ahead here and I'm going to look at the database, and now the database is pretty thin, right? We've gotten rid of a lot of stuff that we didn't need. So we're in pretty good shape there. So, okay, so the remaining thing here is this link between these two, is the SBIs. These aren't point-to-point either. Now, what we can do on switch 7 and switch 8, in this particular case here, if we look at this, we go to global config, and if we do show IP OSPF neighbor, we are forming adjacencies over VLAN 10 and 11, right? And we don't want to do that, and that's why we're seeing what we're seeing. So what I'm going to do is I'm going to go to router OSPF 1 and type in passive interface of VLAN 10 and 11, and do the same thing on switch 8. So router OSPF 1, passive interface of VLAN 10 and 11. Okay, so now that that's complete, if I go back to 25 and I hit the up arrow, we eventually, those LSAs are going to eventually age out. We already lost 10, so there's 11's gone now too. So that's why we're seeing that, because even on the SBIs, they were still doing the network type of broadcast. So that's why we're seeing a type 2 LSA. Now we have a type 1 LSA only. So we've optimized our network just a little bit to make things a little bit better. And we did passive interfaces on switch 7 and switch 8 in order to optimize that network. Now the cool thing about it is, if we wanted to go in here and try to optimize our timers or improve on our conversions, that would be the first thing you'd want to do. If you wanted to do things like OSPF fast reroute or anything like that that would require you to do, or OSPF loop-free alternate, known as LFA, that'd be the first thing you have to do, is turn on point-to-point. So that's one of those caveats that you have to take in the back of your head of what do you need in order for this to work. So that's the first thing that I wanted to do, and that's the first thing you should do when you are looking at doing any size OSPF deployment, is try to optimize your configuration. So the config show run pipe section OSPF is just that, is go to the interface level and do your optimizations. Turn your passive interfaces on, do your network type point-to-point, especially if you're a transit device, you should be doing that out of the gate. It shouldn't be one of those things where you're like, well, maybe I should, maybe I shouldn't. It's one thing, you should just be doing it. You know, it's a default process. I really wish Cisco would go into the code, and maybe they have in newer versions. I haven't really been on any new version of Cisco iOS or Nexus or XR9K in quite some time to see what the disabled features are. In my opinion, like, I know Nexus, I have to go over to Nexus real quick. Let's look at Nexus 49, for example, and if we look at show run all pipe section OSPF, one of the things that was done was right here. The auto cost reference bandwidth is set to 40 gigabits per second. Now if I look at old iOS, I look at the show run all pipe section OSPF, and I come down here to the, notice how it says auto cost reference bandwidth is 100 megabits per second. So they have made changes to iOS or to OSPF over time, depending on the platform you're on. So the auto cost reference bandwidth is still leveraging 100 megabits per second. So 100 megabits per second on an interface is still a cost of 1. So if you're on gigabit or higher, you're automatically going to be a cost of 1. But over here on Nexus, they made it a cost of 40 gigabits is a cost of 1. So if you're at 10 gigabit, right, if I do a show IP OSPF interfaces, you'll see the cost is 40, right? So I do a show IP route, you'll notice that 42. And that's why it shows up that way. It's not because it's wanting to hate on the network. It's because of the fact that you're dealing with 40 gigabits per second is your auto cost. So these interfaces are sitting at 1 gig. So their 10 gig would be a cost of 4 at that point. And since we're dealing with 1 gig, we're scale. We're 40 times slower, so 40 would make sense. So that's just one of those things you got to keep in the back of your mind is when you're looking at an optimization, that's one of the first things you want to look at. Now, I wish the iOS would get updated. Maybe it has. I don't know. So I would have to go look at like the release notes of a newer version of code on iOS XE. And the way you would do that, you would do this. You'd go to, let's go to Google. And we're looking at iOS XE 17 OSPF release notes. And if we look at this for 1712 for the ISR 4K, actually let's look at like the 9300 because that's going to be something that's out. If we look at this, now I don't know if this is going to be what's new. If we look through here, let's do a search for auto dash cost. Yeah, there's a lot of route distinguisher for VXLAN. But so you'd have to go through and see if there is an updated, if anything got updated in the release notes. Sometimes it'll, if we were to look at OSPF auto cost reference bandwidth, right? So reference bandwidth is 100 megabits by default. Now that's for geeks, but if we were to look at, this is 2018, so stay signed out. 21, let's look at this guy. That's sort of new, it's a couple years old. This is 17.6 code, 9400 switches. So if we were to look at the auto cost, still, yeah. So the default is still 100 megabits per second on iOS and iOS XE, even on almost the new brand new releases of code. So if that's the case, then that's still pretty sad, if you ask me. So what would you do in that situation? Well, you'd have to look at your build, right? You'd have to look at what is it that I'm going to be deploying. Am I deploying 100 megabit per second? No, you're not. You're not going to be doing that today. Your downstream interfaces are still going to be gig, right? Your endpoint, your modern network adapters, modern NICs are going to be gigabit, if not 10 gig for a lot of scenarios. So in situations like this, you look at the default OSPF configuration, it says 100 megabits per second, right? So you take that into consideration. If you look at your bill of material and you know what your architecture is going to be, if you look at your architecture and it says that you're going to be using 10 gig and 40 gig, well, then you're going to have to just do what Nexus already has done and change your auto cost reference bandwidth to be 40 gigabits per second, or change it to be even higher, whatever the highest possibility is there, right? That's the mindset you have to adopt when you are looking at situations like this, so that you can adjust accordingly. Nexus already made that change. Maybe iOS XR has as well. I'd have to go Google for it and try to find it. As you can see here, it didn't take me long to find the default version for 17.6 code on a Cat 9400. So Cisco, one of Cisco's latest models, and a pretty recent version of code. Now maybe they've upgraded that since then, but even just a couple years ago, 2021, they had made a change. So these are things to keep at the back of your mind when you're designing your networks, is to keep things like this in mind, so that when you're running into this, you're going to be cognizant of stuff like that when it does pop up and you're like, oh, I got you. Now, how big of a deal is that? It may be very minuscule inside of the grand scheme of things, but the reality of it is, if you're designing a network and you're trying to keep in the back of your head what you're trying to accomplish here, I try to keep it even keeled across the board, because if you have a mixed bag of hardware, like I've dealt with customers that have Nexus attaching to Cisco ASR 1000s, and you have to keep in the back of your mind, well, if I've got a Cisco ASR 1000 and I got a Cisco Nexus switch that are working together, you're going to have two different cost calculations, because each box is independently calculating how OSPF works based off its local reference bandwidth. Now, Cisco recommends you keep them the same across the board. I agree with that. Do that so you don't get an accidental, inadvertently injecting a routing loop into your environment. Small chances are small, but they still can happen. So in situations like that, be cognizant of those things. So keep your configurations the same. Keep your metric calculations the same. Like, I like what EIGRP does, where it's got that K values have to line up. So EIGRP doesn't do what OSPF does. So by setting the auto cost to be a specific value, that's going to benefit you. So you'll be able to predict what the cost is going to be wherever you are in the network. Just little small things to put your mind at ease when you're trying to design and develop and deploy networks. So that's essentially where I wanted to dive in this video, was, let's start optimizing the infrastructure and taking a look at what that comes into play. Now, we still have a lot to go over when it comes to OSPF, but this is just one of those little minor things that I want you guys to be cognizant of when you're, especially those of you that are potentially going after CCIE. The design, optimize, and operate section of the lab, it's there for a reason. So just keep these things in the back of your mind when you're looking at network operations and things like that. Very similar to the way MTU works as well. So with that being said, though, we're going to be diving into more and more of this as we go along. We're definitely going to be spending a lot of time in areas and stubby type areas and things like that. So be cognizant of that. And I'll be spinning up this VXLAN environment here very, very soon in order to get that incorporated as well. So if you guys have any questions, comments, concerns, feedback, drop that into the comment section below. If you haven't already done so, please like, share, and subscribe. And I'll catch all of you in the next video.